For decades, software development followed a rigid path. Programmers mapped every rule, authored the codebase, and explicitly directed the machine through every step. Generative artificial intelligence dismantled that approach. We've shifted from an imperative structure, where we define the exact steps, to a declarative one. Now you simply state a goal, and a stochastic machine autonomously generates the execution path to reach it. When an autonomous agent can produce a complex code library or automate a multi-step workflow in seconds, the cost of computational labor vanishes. The marginal cost of generic digital assets and routine software execution has effectively reached zero. Because execution is now functionally free, the economic value of generic software is evaporating. In an economy saturated with machine-made content, value is migrating away from the act of execution and toward the layer of verifiability. These autonomous agents are no longer just passive tools, they are active economic participants. Right now, automated systems are settling millions of dollars in blockchain transactions and managing high-frequency micropayments without a human in the loop. But handoff to a machine creates a massive trust deficit. These agents lack independent legal identities and operate on probabilistic models. They are prone to logic drift and hallucinations, meaning their reasoning can degrade rapidly if they aren't tied to a real-time verification mechanism. This creates massive financial vulnerabilities. Attackers can feed spoofed data, deploy thousands of bot swarms to distort market signals, and execute Sybil attacks faster than any human can react. You cannot protect a machine-led economy with legacy firewalls or manual oversight. If one independent system is going to trust the output of an autonomous agent, it needs a deterministic cryptographic proof of that agent's data and logic. This demand is driving the rise of trust as a service. Building that trust starts with the data the agent consumes. The Flare Data Connector, or FDC, is a protocol designed to eliminate the need for centralized oracles by embedding data verification directly into the blockchain's consensus layer. When an external event occurs, like a price update on a Web2 API, independent providers fetch that data and attest to its accuracy. Over half of the validator weight must agree on the result before it is locked into a unified block of secured data. That consensus is anchored on-chain as a cryptographic Merkle proof. The AI agent now has an immutable, untampered record of reality to base its next action on. But true data is only half the battle. The agent's reasoning must also be secured. This verified data is routed off-chain into a hardware enclave, a trusted execution environment. Inside this isolated processor, the agent runs its logic in total secrecy. The host operating system cannot see it, and cloud administrators cannot alter it. Once the calculation is complete, the enclave generates a mathematical receipt, a signature proving the code executed exactly as programmed. By combining an immutable record of data with a sealed, hardware-isolated processing environment, any counterparty can trustlessly audit an autonomous agent's financial decisions without having to rerun the computation. Once an agent's logic is secure, how do you safely authorize it to manage a high-value treasury, especially for assets that do not natively support smart contracts, like Xrp or Bitcoin? Older bridging models relied on individual agents holding collateral in their own private wallets. Because those agents could theoretically steal the funds, the system forced them to lock up massive amounts of excess capital just to ensure the network against their own behavior. The F-asset system solves this bottleneck by introducing a decentralized core vault. Instead of scattering assets across vulnerable agent hot wallets, users now mint their wrapped tokens directly into a shared, pooled vault, governed by smart contracts. The autonomous agents can still route value and execute trades, but they are structurally blocked from withdrawing the underlying collateral. You strip the machine of custody entirely. By mathematically removing the risk of a rogue agent stealing the treasury, the system can lower over-collateralization requirements. It creates the capital efficiency required for institutional-scale adoption of the machine economy. With data, computation, and capital now secured by cryptographic proofs, tokens are evolving. They are moving away from passive speculative assets and becoming active, intelligent representatives on the ledger. We are seeing early prototypes of these identities in community-driven entities like MB589 and MG589. An entity like Moongirl, or MG589, is built to function as a verifiable interface. It serves as a recognizable digital identity designed to onboard new users and coordinate community governance. This chart shows how the MG589 token operates within a closed-loop economy. Users acquire tokens to unlock AI services. Platform usage then consumes a portion of those tokens, while the rest are redistributed to contributors, keeping value circulating through utility rather than speculation. As decentralized finance becomes more complex, these identities will act as multi-chain guides, safely navigating users through sprawling networks like Flare, Hedera, and Algorand. Their long-term value lies in their ability to translate complex, trustless infrastructure into accessible, human-centered experiences. When you look at the macro evolution of the internet, the direction is clear. The digital landscape is no longer just a human communication network. Today, it operates as a unified orchestration layer for synchronized systems and autonomous machines. In an environment moving at the speed of algorithms, legacy defenses like manual audits and legal contracts are obsolete. Ultimately, the entire future of global wealth and digital infrastructure will be defended by one thing alone: deterministic cryptographic truth.